So hello and good morning to everyone. So today's lead code question is 1914, that is cyclically rotating a grid. So basically in this question we are given a m cross n integer matrix named as grid, where both m and n are even integers, right? And we are also given another integer k, and the matrix is composed of several layers. So we can see in this example shown over here, this is layer, this is one layer shown with the blue color, this is another layer shown with the yellow color. So basically the matrix composes of several layers like outer layer, then it has inner layer, and so on, right? So a cyclic rotation of the matrix is done cyclic is basically cyclically rotating each layer in the matrix, right? So rotating the whole matrix is basically rotating each layer in the matrix. And to rotate a layer, once, each element in the layer will take the place of the adjacent elements, means so we have to rotate in the counterclockwise direction, right? So see, we are given this example, right? So if you have to rotate once, so each element will go to the place of the adjacent element. You can see over here, like 3 will go to place of 2, 2 will go to place of 1, 1 will go to place of 16. So each element will go to its adjacent element in the counter clockwise direction. So that is rotating one time, right? So see, this is the initial matrix, and after one rotation in the counter clockwise direction, the matrix will look like this. So if you see the outer layer, so see 2 was here and we have to rotate once, so 2 will come at the starting. So see, 2 comes as the starting, then 3 will come at the place of 2, 3 comes at the place of 2. So this way we rotate each layer. And what we have to do is we have to return the matrix after applying k cyclic rotations to the matrix, right? We have to return the matrix after k cyclic rotations. So let's see the examples to get the question more clearly. So we are given this grid 40, 10, 30 and 20, and our k is equal to 1. That means we have to rotate one time, right? So let's see, if we rotate one times, this 10 will come over here, 40 will come over here, 30 will go here, and 20 will go here. So see, 10, 40, 30 and 20. So this is the matrix after one cyclic rotation. So let's see the example number 2. So in example number 2 we are given k is equal to 2, and this is our matrix initially. Now what we do is we have to do 2 times cyclic rotations to the this matrix. So first time, let's rotate the layer number 1. So 1 will come here, 5 will come here, 9 will come here, and this way it will rotate in one direction. So see, the outer layer has rotated one time, like 2, 1, 5, right? Same way the inner layer will also rotate. 7 will come over here, 6 will go to a place of 10, 10 will go to place this way. So see, this is after one rotation, after one rotation, but we have to do rotation 2 times. So again we rotate this matrix now. So if we again rotate the matrix, we'll get this matrix, and this is our answer. So we return this matrix. Now let's move to the constraint part. So m, which is the grid length or the number of rows, n is the number of columns, right? And m and n is up to 50 only, right? And both m and n are even integers, and each element in the grid can be up to 5000, right? And we don't have to do anything with the element, so there is no point of using these things. And k is 10 ki power 9, that is the number of rotations that we have to do. Is it can be up to 10 ki power 9. This is so big, but in the solution we reduce it, right? That we'll see later how we'll be reducing k. So let's see the approach part. So basically it is given in the question, or we can say that our main observation is that every layer of the matrix behaves like a circular array. See, this layer number, this outer layer number 0, right? These elements of the layer, so they all are like a circular array. And so if you see the outer layer or layer number 0, So we have 1 2 3 4, then 8 12 6, 8 12 16, then 15 14 13. So this is our layer number 0. Then we have inner layer number 1, 6 7 11 and 10, right? So now what we do is, instead of rotating whole matrix once, what we do is we pick one layer and then rotate that layer, right? So we do the rotations layer by layer. Like instead of rotating the matrix, what we'll do is we'll perform the rotations on the layers, and at the end when we perform the rotations on all the layers, that is basically rotating the entire matrix. So this is one observation. So first we'll find the total number of layers. So the total number of layers will be minimum of number of rows comma number of columns, and then divide that minimum value by 2. So that will be the total number of layers, right? Then what we'll do is, once we get the minimum number of layers, then we extract one layer. Like, so suppose if 5 layers are there, then we get first extract first layer, then rotate this layer, and then reinsert this layer. Then we do the same thing for layer number 2, layer number 3, and up to layer number 5. So after performing these three steps, on all the layers, we get our rotated matrix, right? So when we extract one layer, what is the order in which we will be traversing that particular layer? So first we pick the elements in the top row, then in the right column, then in the bottom row, and then in the left column. So in this way we'll be extracting the elements of the particular layer, right? So this is the way to iterate over the particular layer and extract the elements. So suppose this is an example, and the layer number 0 is these are the elements of the layer number 0 that we have extracted from the above example, right? So, and we know the layer will behave like a circular array, right? Circular array means they are like, if you see, they will be like somewhat this, so they are like circular array. And now, so after extraction of the layer, what we need to do is we need to rotate the layer k times in the counterclockwise direction. So first we do k is equal to k modulo size of the layer, because after size rotation the same array will be repeating. So if we rotate this array 12 times, then the same array will be appearing. So if k is greater than 12, 12, then we have to reduce that k to lesser than 12. That's why what we'll do is we'll do k is equal to k modulo the size of this layer, that is the number of elements in this layer. So this has 12 layer, what you call 12 elements. So we do k is equal to k modulo 12, which is basically size of the wells or size of the particular layer. So we reduce k. So after reducing k, now next we need to rotate the array. So now here, instead of actually rotating the array, we do a virtual rotation. What does that mean? So see, if we suppose if we have this what you call this, these are the elements of the layer. So the size is 12, and let's say k is equal to 28. So after 12, then 24. So up to 24 rotations, the same thing will be repeating, means the same array. Then how much are left? 4 is left, which we get by, if we do 28 modulo 12, we get 4. So now what we do is, now our k is equal to 4. That means we have to rotate 4 times counterclockwise direction, right? Now if we start from index number 4, where will this index go after 4 rotation? 1 2 3 4. This will be the starting point. Then this index will come to index number 1. Similarly this index will come to index number 2, and this index will go in the end, these four indexes, right? These four indexes will go in the end. So instead of rotating, what we'll do is we'll start picking the elements from this index, like that is 8, then we pick 12, then we pick 16, then we pick 15, then we pick 14, 13, 9, 5, then 1, 2, 3, 4. So isn't it like rotating the array? Isn't it like the like rotating the array k times in the counterclockwise direction? Yes, because see, now after rotation we will getting the this matrix, but we haven't rotated, we just have started picking elements from this index, which is k index, right? So now instead of doing the actual rotation, we'll do the virtual rotation, and we'll start picking the elements from the index that is k, right? And then from index k we'll pick all the elements up to the end, and then start picking from the start up to this index, right? So this way we have simulated the rotation in counterclockwise direction instead of doing the actual rotation. Now after simulating the rotation, we put back all the values in the what we called the same grid, that same layer, right? And we'll be again traversing the boundary in the same value in same order in which we have extracted, that is top row first, then right column, then bottom row, and then left column. In this way we again put the values back, so that means the layer, that particular layer has rotated k times. So let's see an example. So this is the same example, and here k is equal to 2. So first we find the number of layers. So layers is minimum of rows and columns by 2. So row is 4, column is 4, and then we divide by 2, we get 2. So 2 layers are there, and we can see in the example we have 2 layers. So first we extract the layer number 0. So we get 1, 2, 3, 4, 8, 12. So we get this layer. Now we reduce our k is equal to 2 modulo size of layer 0. Size of layer 0 is 12. So now our k is 2. Then we start inserting from index number 2, from index number index number 2, which is from the element 3, right? So we start inserting the element from that index in layer number 0. So we have inserted, see, first we have inserted 3, then we have inserted 4, 8, 12. So in this order we insert all the elements. So now our layer 0 has rotated in counterclockwise direction by by 2 values, right? See, earlier 3 was used to be at place of 8, here 3 was used to be there. Now see, it has rotated 2 times. So this way we rotate the layer number 0, then we extract the layer number 1 and do the same steps, that is update the k, that is 2 modulo 4. Now in layer 2 we have only 4 elements, and again our k is equal to 2. So we start picking the elements from index number 2 in layer number 1, that is at index number 2 we have the element 11. Then so first we take 11, then 10, and then 6 and 7. So after doing this we get the updated matrix, right? So let's move to the code part. So in code part, see, first we find the number of rows and number of columns, then we find the number of layers we have, and then we iterate over each layer, and then we have used a vector int else to store the elements of layer, even we can ignore this, like we could have used only what we call one particular matrix which we declare outside the loop, and then use that re again instead of declaring every time. You can have used done that. So you try that, like instead of declaring this vector inside the layer function, layer for loop, declare it outside and use that again and again, and you could have used a count variable, right? Then we have taken the what you call 4 variables, top, left, bottom, and right? And then what we'll do is, then we'll iterate over the top row, from left to right? So we know the row number, so we iterate from left to right. that is from left index to right index, and pick the all the top all the elements present in the top row. Similarly we do for the right column, then we iterate over bottom row, and then we iterate over left column, then we iterate over left column. So this way we'll extract all the elements of the that particular layer. So after extracting all the elements, we'll find the size of the elements, or we find the number of elements present in that layer, and then we find the starting index, which is k modulo size, right? So we get our starting index. Now we iterate over vals, we iterate over vals using the index, and then we store in the same order in which we have extracted, right, starting from the index. And now if our index becomes equal to size, then we shift the index to 0, because it is cyclic rotation, right? That's why we are shifting the index to 0. So we first fill the top elements, then we fill the elements in the right column, then we fill the elements in the bottom row, and then again we fill the elements in the left column. And this way we do for all the all the layers. And once we do for all the layers, that means if you have rotated all the layers to k values in the counterclockwise direction, that means we have rotated the whole matrix. So at the end, then we return our final answer. So I hope I'm able to explain you the solution properly. So if you like the video, please make sure to like, share and subscribe the channel. Thank you.